Okay, so good morning, good afternoon, good evening from Helsinki, and welcome to the Pulse of Network webinar series, episode 10. My name is Claus, and I'm the CTO of Creanord. And today, I'm very pleased that I'm joined here by Mr. Miika Mattila, Director of Sales Engineering.
Hello, everyone.
Today, the topic of today's webinar is Bandwidth Management Reinvented. So let's start. Okay, so why is bandwidth management important? Let's look at some of the factors that makes it so important. If we start, so today's networks have a variety of traffic on the network. We have video, voice, mission critical traffic, cloud gaming, and so forth running on the network. So we need to make sure that each of these traffic types are getting the performance that they need from the network in a consistent manner all the time. Also, in the cases where we have troubles, so we need to have very detailed information from the network to quickly resolve any issues in order to keep the network up and running. As the traffic that's running on our network gets more and more important, we have all of this critical traffic running there as well, so we can afford just shorter and shorter traffic breaks in order to keep the 5 nines and, as we go into the future, 6 nines of availability figures. We also have to know our network and know what type of traffic we have in the network, where is the traffic, and so forth, so that we can kind of see that the traffic demands that we originally planned when we rolled out the network is actually what we have in the network. And when we look at that, understand also better where the trends are. So looking, we collect history data from the network to see how the bandwidth demands are evolving, and then we understand how the network is evolving and where we are starting to have a bottleneck, so we can then change our network accordingly. We can, for instance, add more capacity to the network or change routing and so forth to ensure that we don't get any performance degradations in the services that we are running on the network. So let's look here at a few of the challenges that we have as we move into the future and what will put more and more demands on the network. The first one is video. Of course, already in today's networks, there's a lot of video running on the network. The majority of the traffic on the internet is really video, estimated at roughly 80% today and just growing as we speak. And the video, why this is important is that the video traffic and particularly streaming video traffic is a challenging traffic type to have on your network because of its nature. The streaming traffic will introduce some additional burstiness into the network, as when you are streaming video, the video is fetched in chunks, and that type of traffic will then introduce the burstiness into the traffic, into the network. And since we are carrying this video traffic on the same pipes as we are carrying the mission critical and the delay sensitive traffic, so that puts some additional challenges on us, how we can keep this mission critical traffic running without degrading it. So we need to ensure that the video traffic is not degrading this mission critical traffic. The second factor is that cloud-based services, these will introduce more and more business critical traffic onto the networks, meaning that we will have to introduce more service classes to manage the different types of data streams. And that means that we also need to have more detailed information for each of the service classes on what type of how much traffic is there for each service class and so forth. And finally, industrial IoT will be a big trend in the future, and there will be more and more mission critical traffic which need very low latencies on the traffic, and that again will call for very high reliability from the network. So we need to make sure that the other traffic that we are running on the network does not degrade the mission critical traffic. Okay, so there are a lot of challenges ahead, and that means that we need to look at new approaches on how we manage the bandwidth. On this slide, we summarize how we think that the bandwidth management need to evolve as we move into the future. On the left, we have where we are today. So traditionally, bandwidth management has been a very link by link based approach. Data is collected from each link by typically Snmp, reported back to a central server. And then as the network evolves, we think we need to move to a more centralized approach where data is collected from centralized locations in the network. And then as the third step, the ultimate end goal is that we, in addition, we also need to include an end-to-end view of bandwidth between locations in the network. And of course, at the core of this all is the 5G networks being introduced, which will introduce drive all of these changes in the networks. Okay, so let's start with the Snmp monitoring, the kind of traditional approach. So in the Snmp monitoring case, we pull the KPIs, the counters from each link with the Snmp protocol, and there are some particular challenges with this approach. When you have network congestions in the network, you may lose the Snmp packets, and of course, if you are pulling this from a centralized location, it will also put some additional overhead on the network. And when we are doing it centralized, typically you get down to a 5-minute interval, so it's not, the data is not that granular. There are some things that you can do to improve this approach, and one thing is to distribute probes across the network that actually does the Snmp collection. So this has multiple benefits. So you are actually distributing the processing work across the network. You have shorter delays because the probes will be much closer to the routers that they are collecting the data from, and they may also then compress the data. Snmp protocol itself as a protocol is not the most efficient in terms of transporting data, so you can then compress that collected data into a more efficient format before you forward it to the central server. And having these probes very much closer to the routers mean you can get down to a 1 minute or maybe a bit sub-minute 1 minute intervals with this approach. You can further also enhance on this traditional approach and link by link approach by introducing smart SFPs. Benefit here is that now you no longer collect the flow statistics from the router itself. You are collecting it from the smart SFP, meaning that you are offloading the router from this work. Routers can sometimes be quite congested in terms of the CPU utilization, so you get that work off of the router CPUs. And again, also in this approach, you can transfer this information in much more compressed format, and you can also use guaranteed delivery by transporting it using TCP rather than UDP. One thing that you have to consider when looking at the smart SFP solutions is that as we move into the future, the 5G networks will introduce more service classes into the network. So you may have up to eight service classes per base station, potentially even in separate VLANs. Or the other case is also that you may collect flow information, put the smart SFP a little bit more centralized, so you collect flow information from multiple base station. Then again, each of the base station traffics will be in separate VLANs. So when you look at the smart SFP approach, you need to make sure that the smart SFPs you are deploying can monitor more than 10 VLANs at least to cope with the future demands. Okay, and I will now hand over to Miika to continue on more advanced approaches for bandwidth management.
Thanks, Claus. We will next cover about a proposition of how to do bandwidth management with today's requirements in scale. So we see that in future, or as is happening at some of our customers already today, the direction will next be towards centralized solutions. And as an example scenario of this, we can use a mobile backhaul operator who has 20,000 cell sites. If we first consider that we would use Snmp polling to get the visibility to all the traffic flows needed, and we would query the cell site routers port utilization statistics for that, we could realistically do it perhaps once per 5 minutes, like Claus was saying, or maybe once per minute. But the requirement today is starting to be second-by-second granularity, or at least every 10 seconds. So it would simply just not cut it. Polling at high frequency would actually destroy the performance of those smaller cell site routers, and such would also induce even more traffic in the access network, which could already be congested. So we would not be solving anything in a good way in this example scenario by this, but in fact, we would rather be making an existing problem worse. If we next consider that we would use those smart SFPs to get the second-by-second granularity visibility, the bandwidth utilization statistics per each service level flow, meaning each class of service flow within each of the VLANs, using the smart SFPs, it is already a much more possible approach technically, considering today's requirements and modern smart SFP capabilities. However, in this example scenario, we would need to install those smart SFPs down the stream at cell site router sites, and we would need 20,000 of them in this network, how it is set up. And everyone can easily understand that price for that would simply become too high. Plus one would also need to factor in all the truck rolls, installation cost, and the need of agreeing and cutting each of the links for a while. Also, there would then be those 20,000 SFPs to be managed somehow, and they would induce a lot of data to be sent through the network, both for the management and also to dispatch the measurement results. And because of all of these reasons, also this approach just would not fly for such larger deployments. So something else was needed also at this customer. And from here, we come to the idea of using centralized monitoring probes in sites like HiRAN in this picture to monitor for the flows. And we can, of course, do that here because the same flows as in the access network, well, they travel through those HiRAN site routers as well. And there it will be easy to tap in to say the 10G optical links and start categorizing packets. Even by just a 1U high modern appliance with suitable capture card and software, we can do it for instance, up to 8 times 10 G links, which all in all could have thousands and thousands of service level flows to be managed and reported on. After that, it is simply up to the management and reporting solution to offer us tools for real-time situational awareness, visibility, troubleshooting, and correlations and reporting. So this is where we see the market is going today, and especially so starting from the larger scale deployments. And it is really possible to get second-by-second visibility using a solution like this and even below. And the same approach, by the way, is not applicable only to mobile backhaul, but to any network, including also most of enterprise networks, when traffic is flowing through the bigger pipes in some focal points. Yet another angle to be covered here is that when we talk about passive centralized bandwidth management solutions, our potential customers sometimes say that we already have this flow-based thing. Yes, sometimes these flow-based things, they are used also for bandwidth management, but there also you have the challenges with granularity and scalability. And you should also consider whether you really want to use the resources of your most valuable devices, meaning your routers, for this kind of tasks, or whether you'd rather want to offload that task to a less expensive solution, which is also purpose designed and built for such tasks. And whereas the centralized non-intrusive passive monitoring solutions, like the ones presented in the last slide, are making their entry to the market right now, many times today, also the more traditional and common service activation and throughput metering test types are used to find out about the bandwidth utilization, or rather the available bandwidth through the network. The approach with these measurement types is that you just send data through the network, and whatever passes, then that was the available bandwidth at that moment. And to be more on the safe side, you could also send your packets with lowest priority markings to do your best in avoiding pushing out any other traffic. This method may not be the most optimal solution in a live network scenario, but in many cases, it is still a well acceptable way, at least to run sometimes, to find out how much bandwidth is available. So this can be a well acceptable approach for that. In fact, we have several customers who run such testing periodically and mostly at low traffic times to know that the bandwidth that should be there will really still be there for when needed. An example of this could be smaller public safety locations, offices, where especially in mountain or coastal areas or seasonal touristic areas, their broadband connections are often via mobile networks, and there is simply a need to validate throughput of that connection every once in a while, like for instance up to a few times a year, and especially at high season when networks are loaded. Depending on availability of suitable equipment at these smaller location sites, the used measurement type could be RC2544, Y1564, or RC6349. These types are often used towards regional locations, and towards the smaller locations where measurement options are typically less, still a perfectly acceptable available way is iPerf measurement. Connectivity speeds to be tested towards these locations is typically only up to maximum of 300 or 400 megabits per second, and iPerf can easily do this, and it's definitely with good enough accuracy for that kind of checks. With an easy to manage solution, testing even bigger amounts of such connections a few times a year is really not that big of a deal. Plus, it can obviously also be automated. All of these service activation and throughput metering testing types, which are covered in this slide, are intrusive in nature. But nowadays, and which takes us to the next really exciting topic of the next slide, also non-intrusive ways exist. So, whereas the measurements in the previous slide were all more traditional and of intrusive type, meaning that they try to push through traffic in the network as much as was intended. The topic here in this slide is about something very new and something that we are very, very excited about. This topic of being able to figure out bandwidth or available bandwidth between any 2 points, but without filling the path in between with traffic to find it out, has been an almost endless source of university studies. If you search the internet about it, you can easily find dozens of methods and algorithms, several dozen papers studying about them, and even at least a dozen studies made of these previous studies to study on their quality. So truly it has been an interesting topic, and already for over 2 decades. And obviously also we have been looking into this already since a few years back. But when we back then first experimented on some of these theories and algorithms, still at that time, the results were just not good. Accuracy was not there, but it was like all over the place, not even in the ballpark. And we dropped the topic for a while. However, we have lately taken another look at this, and today we can already say that we think that we have really made it, and in a really, really good way. What I mean with this is that when we started the coding work about it this time around, we set our target to be 90% accurate in reporting of available bandwidth using this method, but by today, we have already reached 97% accuracy with our methods and algorithms in our lab and live network testing. So that's almost as precise as doing it with the intrusive test types we discussed in the previous slide, but unintrusively now. And that is really an amazing result. And yet another punchline here is that even though this topic has been studied by so many and for more than 20 years by now, it is quite astonishing to realize that by today there seems to be only a couple of companies in the world that can offer this as a real telco-grade reporting solution. Thinking about the use cases for this, well, they're just vast. We, for instance, were contacted about this by an electricity grid operator who has some megabits per second of reserved bandwidth between their stations, and they just have to know that the available bandwidth is there all the time on constant basis for important dispatches of information, which could happen anytime. There, one could obviously not fill the channels with intrusive tests to find out about the available bandwidths, like using of the test types of previous slide, because that could disturb really important traffic. And that's just one use case example. Others include gas and oil pipeline stations and so on. And apart from these, there are projects like connected schools. And as probably the most promising area for this is the public safety sector, including network slicing of the future. So this is something really, really exciting. And the next areas for us to look at for positioning this are data centers and cloud. And to summarize now a bit about what we have discussed so far. So we at Creanord have been working very hard during the past few years to develop telco-grade testing solutions to answer to the different kinds of testing requirements, also in the area of bandwidth management. And today, as we look at our complete offering in this area, we can proudly conclude that there are good options available for any size of deployment and for any sort of need in this area. What's more, as you can see listed in this slide in the middle column, is that many of our solutions even come with some special features that differentiate Creanord from our competition. It really makes a compelling set of options to choose from. Well, I think this slide pretty much talks for itself, and I'll just leave it at this from my side. And so I think it's back to you, Claus, for any final words before we will conclude this webinar.
Thanks, Miika. All right, so let's conclude a little bit what we went through. So as we talked, as you move into the future, you will need to have much better granularity for your measurements for the bandwidth, to be able to understand what's the new type of traffics and the new challenges that you have in the future data networks. There are some incremental things that you can do to your current link-based approaches. You can distribute probes in the network to distribute the collection. You can introduce smart SFPs to get better results. But we believe that for the big networks and to get really down to very granular visibility into the network, you do need to also consider the centralized monitoring approach, where you have the specialized probes that will provide the granularity and scalability that's needed, and also as at the cost that you can then afford. And then as you look further, and as Miika went through here last, so a very exciting part is that you also need to consider the end-to-end monitoring approach for particular use cases, like when you have the need to ensure that the bandwidth is available, and we are. This is looking very promising for us, and we think that we have it very available very soon for you to introduce into your network. And basis for it all from Creanord, we have the PulseShore solution that will provide you a future-proof solution with very granular and good visibility into your network for your bandwidth management. And furthermore, you can also combine that data with active data like TMAMP and other protocols to get really a deep view into your network. So just shortly about the PulseShore, it's a full solution to get all of the service assurance capabilities that you need, including both the passive data and also active data, so that you have a single central solution providing you all the data you need to understand how your network looks like, where you have potential bottlenecks, issues, and make sure that you are running it really at the performance levels that's required. And it's a solution we have deployed worldwide and in more than 60 customer networks. That's all for today. So if you have any questions, please do send us an email. You can see our email address there on the bottom of the slide. Check out our websites. Check out also the other episodes of the Pulse of Network webinar series, and contact us, and we'll be happy to give you a demo of the system and tell you more on how you can make sure that you are successful also in the future and with the future demands for the bandwidth management. Thanks.
Thank you.